this Comic-Con in a bizzle, pushing buttons and it's got me on my mind. I gotta watch my weight because Alina made me slide. So, dog, I got the pounds of fucking bitches.
Yo, guys, AP Maksym here. In this video, we'll be doing modular arithmetic, and the main statement of modular arithmetic is A mod B means that the remainder when A is divided by B. So let's say we have 17 mod 5, right? 17 divided by 5 isn't going to give you a full number, right? So you're going to need to go as many as you can. So 17 minus 5, you get 12. Then 12 minus 5, you get 7. Then 7 minus 5 is 2. So 17 mod 5 is going to be 2. And one useful way to think about this is if you think about it as a clock, right? If it was 9 p.m., right? 9 p.m. and let's say 6 hours passed. So 9 plus 6 is going to give us 15, right? There's no 15 a.m. or 15 p.m., right? So we're going to need to go back around the clock and restart again. And if 6 hours pass after 9 p.m., we're going to be at 3 a.m. So we're going to go again. And so basically, the word modular itself comes from the word modulus, which again comes from the Latin word modus, meaning measure. So in modular arithmetic, the unit modulus, like the 5 in mod 5, is the unit you're measuring with. So mod 5, you can just rewrite it or think of it as groups of 5. So if you have, again, 17 mod 5, we want to put 17 in groups of 5 and see what the remainder is going to be. So if we put 17 in groups of 5, the remainder is going to be 2. Let's move on to some practice problems. Okay, now let's look at this question. It states to find the remainder when 7 to the 100 plus 3 to the 100 are divided by 10. Okay, so looking at it, it looks a little confusing, a little scary, because 7 to the 100, what could that possibly be? But using what we just learned, you can see that it wants us to find a remainder, and it's divided by 10. So we can rewrite this as 7 to the 100 plus 3 to the 100 mod 10. That's what they're asking us. This is going to be x, I guess. And still, we didn't get too far. But one thing that we do want to look for is the cycles when you put these numbers up to different exponents. So, for example, if we take 7, alright, 7 to the 1 is going to be 7. 7 to the 2 is going to be 49. 7 to the 3 is going to be 343. And let me think. 7 to the 4 is 2401. And now we need to look at how do these relate to 10, right? So looking at 7, what's 7 mod 10? It's just 7. So 7 mod 10 is 7. 49 mod 10 is going to be 9. 343 mod 10 is going to be 3. 2401 mod 10 is just going to be 1. So if you go any further, if you go like 7 to the 5th, you're going to see that the remainder of whatever the number is to the mod 10 is still going to be 7. So we're going to have this repeating loop. And if you notice, 100 is just this repeating loop 4 times. I mean, not 4 times, 25 times. So you have 25 times. No matter how many times you do this, the 4th is always going to be 1. So 7 to the 100 mod 10 is going to be 1. Keep that in mind. Now let's talk about the same cycles, but for 3. 3 to the 1 is going to be 3. 3 squared is going to be 9. 3 to the 3rd is 27. And 3 to the 4th is 81. So what is 3 mod 10? 3 mod 10 is 3. What is 9 mod 10? 9 mod 10 is 9. What is 27 mod 10? 27 mod 10 is 7. And what is 81 mod 10? 81 mod 10 is going to be 1. Same thing as 7 to the 100. 100 is, again, a multiple of 4. So we can do the cycle 25 times, it doesn't matter. We will always end up with, as a multiple of 4, we will always end up at 1. So with the 1 remainder from the 7 to the 100 and the 1 remainder from this, you can just add them up because these remainders are at the end of the digit because it's divided by 10. So you're going to have a remainder with a final answer of 2. Okay, and knowing the capable students you are, I wanted to leave you guys off with a little bit of a challenge about today's lesson. What is the remainder when 999 to the power of 999 is divided by 8? And I'll leave you guys off here. Thank you for watching, and